All right, here's a big one. This is one of the more important targets, this 72, because it's finding an exponential equation through 2 points with an asymptote. It has a shift in asymptote, therefore we're going to use a shifted table to form our shifted equation. What I mean by shifted is, usually when we do exponential graphs, they curve like this and they have asymptotes at 0. Well, now we're doing exponential graphs that have shifted asymptotes, which means the asymptote is somewhere shifted above 0, and it might curve away like that. It can also curve down. We have exponential decreasing functions as well with shifted asymptotes. So we're writing equations for those. The tool that we need to learn is that we need a third column in our table. Not only do we need an XY table for the data that they gave us 122 and 320.125. That's all fine and great, but it says it has a horizontal asymptote at 20. That means it's kicked up 20. So what we need to do is we need to create a third column in our table that's called y minus 20, and we need to build our equation from that. You guys, the most important table, or the most important information comes from this third column of the table. You're going to build everything from this column. Any number that's in here are the numbers we're going to want to use to actually build our equation. The results are going to help us get the accurate table and equation and stuff, but we use everything from here. That's the new strategy. So pay attention to only numbers we write in here. Those are the only numbers that matter. So what we do is we say, oh, we've got y minus 20, so I need to take 20 off of these. Well, that would leave 2. It would leave 0.125. Now, we've learned this strategy numerous times where we take the next number in our list divided by the previous. So we're going to do next divided by previous, so 0.125 divided by 2. And then, because it's 2 numbers away, 1 to 3 is 2 numbers away, I'm going to take the second root. Well, we know that as being the square root. So I'm going to take the square root of that, which gives me 0.25. Now I know that this is multiplying by 0.25 each time. If it's multiplying by 0.25 each time to go down, then if I divide by 0.25, I'm going to get to that ever important 0th number in my table, which is going to be right across from there. Then I would divide this by 0.25, and that would give me the number 8. So now I've got all the numbers. I've got my b value, which is right here. This is my a value of what it starts at. My b value is what it goes by. I'm going to write my equation in the form of a times b to the x and then plus a k, which is my kicked up value for my asymptote. So my equation is built from this y minus 20 column. The y minus 20 column is telling me that my a value is 8. It's multiplied by 0.25 to the x. That's what this is telling me, because these were the numbers that I figured out. Now, we know that it's kicked up 20, so I'm going to move this 20 over to the other side. So I add 20, and my final equation is y equals 8 times 0.25 to the x plus 20. And that is the answer that I'm looking for. Now, if you were to put that equation into your calculator and type that in with the y equals, you're going to find that what that does is that puts the correct table for the accurate data that you had when you would do the original problem. So there it is in my calculator, and then I'm going to go second table, and when I do that, you'll see that 0 is 28, 1 is 22, and 3 is at 20.125. All of these numbers are the correct numbers that you would have in the actual table. We just created our own third column to help us figure it out, to do the math. This is not the answer. The answers are in here. This is the correct table, but this equation builds it for us. Okay? All of the data from the shifted asymptote column of our table is what we're going to be using.